Hello, algebra students. Well, today we're looking at section 6.8 and specifically radical equations. So these are just equations that have a radical. And the ones we look at today will have square roots, but you could also have third roots or fourth roots or so on. We have this reminder, first thing up here, that if you take the square root of x and then you square that, okay, like this, the square root and squaring, they're opposite operations and they cancel each other out. So this square root of x squared is just equal to x. Okay. So that's the approach that we use. We will square both sides of the equation. And let's look at this first one. We have a radical on each side. So I'm going to rewrite this so that we can square it. We will square both sides. And then squaring it cancels out with the radical. So we have on the left just negative 5 minus 2k equals, and on the right, the 3k plus 20. So whatever was inside that radical, that's what you get after you square both sides. Okay, so this is just an equation, a linear equation that you guys know how to solve. So let's subtract 20 from both sides and add 2k to both sides. Okay, so we subtract 20. That gets rid of the 20 on the right side, correct? And it leaves us with negative 25 on the left. 20 on the right side is gone. We have negative 25 on the left. We're going to add 2k to both sides. So the negative 2k will be canceled out, right? It's gone. And when we add 2k to the other side, we get 5k. And now we divide both sides by 5. We get k equals negative 5. Gonna squeeze that in there a little bit. Okay, let's look at the next one. So here again we have a radical on the left. And so we want to get rid of that. So we will square both sides of the equation. We'll get a new equation that then we can solve. So on the left, when we square that, the squaring cancels out the square root. We're left with just the p minus 6. Move that up so we don't have to squeeze it in so much this time. P minus 6 equals 64. So add 6 to both sides. P equals 70. Okay, now let's look at the next one. So this one's a little different. We do have a square root there, but we are not going to make any progress if we square both sides the way this is. Okay, let's look what would happen if we square this side. Just look at that side, and we could write it on both of them. Okay, what would happen if we square that side? Well, we would have to take this. Here's what it looks like to square that side. 11 minus 10x minus 10, and that entire quantity would be times itself, right? That's what it would mean to square that side. And on the other side, we'd square it and we would get 1. But this isn't going to do any good, right? When we take this times this, yeah, the square root will go away because we're in effect squaring that, taking it times itself. So square root would be canceled there, but we also would have to take that times that. That's going to have a square root in it, right? And we're going to have to take this times this, and that will have a square root in it. So we will not get rid of any square roots with this approach. So I'm just going to erase that. We will end up still having the square root. So what do we do about this? Well, notice what we want, this needs to be by itself on one side of the equation. Then everything will be fine. So how do we get that by itself? Well, we just add 10 to both sides. And on the left we have 9. And on the right we have just the square root of 11 minus 10x. That's all we've got. Now we can square both sides. And since this is going to be in the notes, I'm going to go ahead and rewrite this so it'll be clear what we did. We squared that side, square that, we get 81 equals, and squaring cancels with the square root, and we just have 11 minus 10x. Now we can solve that. We'll subtract 11 from both sides, and we get 70 equals negative 10x. Divide both sides by negative 10, and we get negative 7 equals x. And that's our answer. X is negative 7. Okay. So we just have a couple more problems here. This time, let's just do the squaring in your head, so to speak, without writing it down. We square the left. I'll just make a note over here that what we did was we square both sides. And what that gives us is, on the left gives us 4, and on the right, when we square that side, it cancels out with the square root, right? And we have n over 3. And now we'll multiply both sides by 3, of course. We get 12 is n. 12 equals n, or you could say n equals 12. Okay? So one more. Now we've got a little work to do on this one. We would rather have this 8k by itself. Now we could square both sides this time and get rid of the radical, but we would have a big number, right? We would have negative 24 squared, whatever that is. Then we could solve it. We would not produce extra square roots. I'll take extra radicals. Let's just take a look at what that would look like. When we square that on the right, well, what that is negative 6 times the square root of 8k times negative 6 times the square root of 8k. And we would take negative 6 times negative 6 would be positive 36. On the left, we could also square the negative 24, of course. That's the negative goes away. Negative times a negative is a positive, and it's just 24 squared. And we, of course, could calculate what that is. But we're not going to do it this way, so we don't really care. This is just to show you that we could do this. We could multiply this out. That's what we're doing here, squaring both sides. And we would take the negative 6 times negative 6 is 36, and this times this. And this is just multiplying, you know, the coefficient times the coefficient, and then the radical times the radical. Well, that does cancel. The radical is canceled, and we get our 8k. Okay. So that would work. We could then solve for k. However, I'm not going to do it that way. It's going to be easier to first divide by negative 6. Okay, we might as well do that. So negative 24 divided by negative 6 equals, over here we have negative 6 divided, or negative 6 times the square root of 8k. We'll divide that side by negative 6 also. On the left we get 4. On the right, you know, this cancels. We have the square root of 8k, and we square both sides now. We'll just write over there so we'll know what we did. And you get 16 equals 8k. Squaring cancels with the radical, right? Now divide both sides by 8, and we get 2 equals k.